Alright, this video is about introduction to matrices. Alright, so first of all, you need to know this. Matrices is plural, as in you have more than one. Matrix means you have one. Just so you know, a matrix is described by a capital letter. So whenever you see this capital letter A, I'm referring to matrix A being the capital letter. Also, description of matrices, it deals with its dimensions. Dimensions is this number of rows and columns. The dimension goes rows by columns. The rows are horizontal, the columns are vertical. So this matrix has 2 rows, and then 1, 2, 3 columns. So we say this matrix is a 2 by 3 matrix. And that's how we describe it, 2 by 3. All right, so those are good little facts to know about matrices. Now let's put it to use. All right, for example, this is a question. Question is, what are the dimensions of each matrix? So this is a matrix. So each side is rows and columns. It has 1 row, and it has 1, 2, 3, 4 columns. This is a 1 by 4 matrix. Right now, pause the video and write down the dimensions of the next 2. So pause it and give it a shot. All right, if you tried it, this matrix has 1, 2 rows by 1 column. So it's 2 by 1 matrix. This matrix has 1, 2, 3 rows, 1, 2, 3 columns. It's 3 by 3. All right, this is really important because the number of rows and columns meet. So this is a square matrix. Square matrix has the same number of rows and columns. So 2 by 2, 3 by 3, 4 by 4, etc. It has lots of really important properties. We're going to work with square matrices a bunch. So just keep in mind, whenever the rows and columns are equal, it's a square matrix. All right, another example. All right, this topic deals with scalar multiplication. Sounds fancy, but there's not much happening. Scalar multiplication means that we have some number that multiply into a matrix. Basically means all the numbers are scaled up by that product. So if I have a negative 5 outside this matrix, this is equal to a new matrix. And that new matrix is negative 25, negative 30, positive 20, negative 20, 10, positive 5. So basically what that means is to multiply everything in this matrix by the number outside the matrix. If there's no sign between them, that means they've been multiplied together. That's scalar multiplication. This is my scalar, and I'm multiplying it. This is the scale of multiplying everything by. So that's what that means. All right, next topic. All right, this topic is about adding matrices. First of all, in order to add or subtract matrices, they must have the same dimensions. That's rows and columns. So this matrix is a 3 by 2. Other matrix is also 3 by 2. So they're the exact same dimensions, so I can add them. How do you add them? Basically add the corresponding elements. What is the element? Each number within the matrix is an element of the matrix. So these are all the elements of the second matrix here. So you're going to add the corresponding elements. This is the one in the first row, first column. It adds to the one in the first row, first column here. So 3 plus 0 is 3. And then 6 plus a negative 1. So that's 5. And then 1 plus 6, also 5. A negative 1 plus 6. Negative 3 plus 0 is negative 3. Negative 5 plus 2 is negative 3. Negative 1 plus 3 is 2. So that's the sum of those two matrices. Once I add them together, I'll come up with that matrix. So again, once you see that they have the same dimensions, you can't add them or subtract them. All right, new example involving matrices. And this one says solve the equation for x and y. So I got addition happening and also have scalar multiplication. By having this 2 outside, I can distribute it into all those that's inside the parentheses. So either I can add them first or I can distribute it first. Doesn't really matter. I'm going to add it first to make it one matrix. So if this is true, I'm going to have 2 outside the parentheses. But inside, 3x plus 4, it's going to be 3x plus 4. This is a matrix, got these brackets on it. And then 8 plus a negative 2 is 6. Negative 1 plus 1 is 0. 5 plus negative y is 5, subtract y. And that's equal to the other matrix. 26, 0, 12, and 8. Alright, so keep in mind, this is a parenthesis right here. Make the parenthesis look bigger. So it just means 2 times that. So it basically means I'm taking 2 and distribute to everything in the parentheses. So that makes it a 6x plus 4. A 12. The 0 stays. This becomes 10, subtract 2y. Actually, that 4 becomes 8. Because everything is multiplied by 2. So it becomes 8. Equals to 26, 0, 12, 8. Alright, keep in mind, all the corresponding elements have to equal. So this 0 must equal that 0, and it does. That 12 matches that 12, and it does. This 6x plus 8 must equal to 26. So I know that 6x plus 8 has equal 26. And I know that 10 subtract 2y has equal 8. So I can solve each of these little equations. This, I'll subtract 8, divide by 6. So 6x equals to, I want to say it's 16, divided by 6. X is 16 over 6, which is about 2.6 repeated. Math's right. And in this next one, I subtract 10. Negative 2y equals a negative 2. Y equals to 1. So I know y is 1. I know x has to be 2.6 repeated, or 16 over 6. Alright, so that's about all. What is about all? Well, last thing I want to mention is this. Last thing I want to mention is addition of matrices is commutative. What does commutative mean? Commutative property says a plus b equals a b plus a. Meaning I can turn it around and be the same thing. For example, with numbers, 3 plus 5 must equal 5 plus 3. And that's true because they both give you 8. Matrices is also true. So if I gave you the matrix 1, 2, 3, 1, and the matrix 2, 2, 1, 1. If I change it around to be 2, 2, 1, 1, plus the other matrix, which is 1, 2, 3, 1. The sum is going to be the same. This sum is 3, 4, 4, 2. And this sum is 3, 4, 4, 2. So you can turn it around and be the exact same thing. Now, is that true for subtraction? If I had the number 3 subtract 5, and I rewrote it as 5 subtract 3, are they equal to each other? Well, no. Not commutative. It's not commutative with real numbers, and it's not commutative with matrices. So if I turn that around and call subtraction, you will not get the same answer. But with multiplication of matrices, for example, with real numbers, If I said 3 times 5 is equal to 5 times 3, well, that's true. It is true. So multiplication is commutative for real numbers. Multiplication is not commutative with matrices. If I had a matrix A times B, it is not equal to B times A. Well, it should not. Generally isn't. Only in special cases that it is. But it generally is not equal to it. So multiplication, you can't assume it's true just because you turn the order around. If it is, it's something special about the matrix. They just so happen to do that. But that's very rare cases. Generally, they don't. All right, so that's all I have. Good luck.